Our aim today is 11.3 normal distribution, and your homework is Delta Math. So, normal distribution. Many populations have a distribution that can be described as the normal distribution or as the bell curve. This curve shows the percent or proportion of normally distributed data sets that lie within certain amounts from the mean. The majority of any normally distributed population will lie within one standard deviation of the mean, but the vast majority will lie within 2 standard deviations. And I'll explain what that means in future slides. So the center or pinnacle is the mean. So that'll be right here. And this is also known as the median and mode. Notice how this graph is symmetric. So we'll know that the median is right here because it's dead center. Now, these numbers that you see here, these represent the percentage of our overall curve, which adds up to 100%. And the portion that falls within one standard deviation would be from -1 to 1. If you're at 0, you're at 0 standard deviations away from the mean. So here at this portion, you are the mean or median, and also the median, and the mode, because notice how high it goes. That's where most of your data is clustered. That's really where a lot of your data is clustered, right there. Okay, so to lie one standard deviation from the mean would mean that you are lying that's approximately 68.2% of your population if everything was symmetric. If you're 2 standard deviations away, you're adding up the numbers from -2 to 2, or the percentages, and that's 95.4%. And if you're 3 deviations away, that would cover 99.7% of your population, while that 0.1% on either side would be further deviations away. You can think of this like SAT scores. You have a bunch of people who are clustered around a particular SAT score, and then you have those that get like around 1,600 or so. That would be this tail end. Of note, I did some research this morning on SAT scores in New York City. And if you're interested, I can give you the link at another time. But the average SAT score, according to the National Center for Educational Statistics in New York State, is 1,052, with a standard deviation of plus or minus 188. So I know that some of you guys are right now taking your SATs, or you've already taken them and you're awaiting your score. It's probably worthwhile if you want to see where in that spread you would fall. So let's look at another example of normal distribution. Here we have the average US male height distributed, and you'll notice here that it's our solid purple. And that is compared with OkCupid, which is a dating website, and their height distribution. Now, you'll probably notice that there are some differences in these two heights. From this data, can we conclude that taller men have a harder time getting dates, and hence why they're on OkCupid? That must be the reason, right? Well, of course not. They are lying, and I am shocked. Not really. But this is the sort of thing that you see. People tend to lie on dating websites about, their height or their age or different things like that. And they usually tend to do so within a trend. Notice how they're all shifted about the same portion. People will add an inch or two onto their height to make themselves seem more appealing to their prospective suitor or whatever. Okay, so now what is skew? data is not always symmetric. Uh, when there are outliers, it skews the data or throws it off. This creates a tail. And the tail, if the tail is on the right, it's known as a right-hand skew. Or if the tail is on the left, it's known as a left skew. So for example, if you want to compare SAT scores, again, if you were to look at the SAT scores for just our school tends to have a left skew, where you guys tend to be past the normal. If you were to look at you guys as like as your own specific subset, you would have a left skew because you guys tend to do better on standardized tests. So let's look at an example. The weight of oranges growing in an orchard is normally distributed with a mean weight of 7 ounces and a standard deviation of 1 ounce. Using the empirical rule, determine what interval would represent the weights of 99.7% of all oranges in this orchard. You might actually remember from the previous slide, and I recommend that you go back and use that when you're doing your delta math. 99.7% would represent those that are 3 deviations away. So if your mean is 7 and your standard deviation is 1, you want to calculate all the ones that are 3 deviations away, as this graph would indicate. So we start off at 7, and 3 away would get us 4, and it would also get us 10. So our interval would be between 4 and 10. Now let's look at another example. On a test that has a normal distribution, a score of 78 falls 2 standard deviations above the mean, and a score of 50 falls 2 standard deviations below the mean. Determine the mean of the test. So here, it's important to first draw out a number line. And when we get this, notice, let me go back for a little bit. Notice here how you have 4 spaces that are in between. It's almost like they're leapfrogging 4 spaces. So you want to know what each of those spaces is worth. And each of those spaces, it's worth 7. So in order to get to our mean, x bar or mu, we would have to add 7 twice to 50 to get 64. And that's how we can determine that our mean is 64.